Welcome to another video on my roller track made of fischertechnik, which is programmed in Python and ultimately controlled by this BeagleBoard embedded system running Ubuntu Linux. The connection between the BeagleBoard and this robot interface is by USB, connected ultimately by this USB hub, also connected to network by this USB Ethernet dongle or converter, and also by HDMI cable towards this monitor, which is necessary to put it properly. After some time, because of lack of keyboard and mouse, it gets inactive. Also this small band cable for serial connection, necessary also to boot it properly. Then this is the start of the roller track. Here the change in direction can be made this direction or this direction, and last time I was creating this part of inverted conveyor belt, so that is where I will continue. So let's see how everything ends up this time. Alright, so now you can see my Linux computer, where I have here Tiger VNC, because that is what I also forgot to mention at the beginning. This is running on the BeagleBoard, visible through VNC, virtual network computing, and this is what I run on the Linux desktop laptop, as well as this. So this I should name to Minicom terminal, where I do have to look at to put everything properly. And everything works fine right now. So let's go to where I left this last time. So using cardan joints from this motor here works kind of nice, with the exception that this works now the wrong way. So this one runs that way, pushing everything underneath forward, and this one runs exactly the opposite way. So I had in mind, because of a lack of a motor, to use this and put it somewhere here. However, then this distance is too short, so I would have this somehow, this axle removed here or here, most likely here, put this inside, and then it would run nicely. So in other words, you have then like this, and where this one runs this way, this one will automatically run the other way. However, I bought a new motor with gears, and that enables another possibility, because now I have a motor here, I have a motor here, and then I would have a motor here, but where do I put the motor? I can put it here, and that would enable me to remove all the cardan joints and this stuff, which is not well, not the easiest to do. And then some wiring, but another problem is that I noticed that when I take off this wiring, the other the load of the interface, 9 volt load, gets lighter. So what will happen here when I connect this one? Will this be too much? Well, this is a small motor anyway. So I'm not quite sure what to do first. I can imagine doing this first. So let's do that. Alright, with a little bit bigger camera view on the situation. So simply put, instead of the cardan joint on the axle, I put a gear on it, and then this is the ultimate idea. But as you can see, that's not going to work out because this is a far too sharp angle. So what can I do? I could put a much longer axle here, where it comes somewhere here. Then have this, of course, here, and then also I have to put something here, this block perhaps, but that block also has to be connected right here somewhere. So that's going to be a puzzle. Can I do that? Well, let's just try. If I find an angle, an axle that's long enough to be kept there, but it's going to interfere with space that I have, which is limited. So who knows? So another reconstruction. Longer axle, as said. This has been well expanded, slightly going up, and then here connecting. Haven't tested yet, so I now have to do it differently, because this is where I have everything set, and does it run? No, it's not. It is not running at all. Can I move it by hand? This runs. Okay, wait. So this is running. This is not running at all. No. Is this running? I can barely move it. So I am afraid that it's not going to work out. Let me do it different. I am going to take this off. Hold it in my hand. And then, and this is going to be a bit hard. Shift it down. And then you won't see anything. And this is working. This is working. So this is still working. This is also still working. So where does it stop working? This is also working. So here it stops working. And now that is where it stops working. This is still working. And this also works. So what is the bottleneck? connecting, and that is the bottleneck. So the whole of the cardan joints do work, but when I connect the gears, they stop working. And that's an oops. Because this is obviously what should have happened. Well, this doesn't go fluently either, but it does work. But apparently the power needed to get this gear working is too much, unfortunately. Which means that I have to introduce this motor with gear. So let's do that. So now I have constructed with the motor, cardan joints no longer in connection, so I can take them away completely. And when I use now this one, it works nicely, which means that I can now also run the Python code. Which I can't because I have to close this interface, and now it can. That means like this. And then something here is happening in the sense that one bullet here, one marble here doesn't let go. So now I face a different problem. That the gap here is way too wide, which was not the case, but is now. But let's test how this works. So let me put these bullets, marbles, take them all that I can, put them in here. I just now have to test everything. And here comes one. It's being transported very nicely, so that works. Two more from here. So this works. Now for the rest. Because there are still a number of flaws. And one of these has also fallen off. So is it perfect? I don't think so. Alright, and now I have everything of the cardan joints taken off, and what I wanted to show is the schematics. So 1, 2, 3 motors which drive a conveyor belt to transport on the lower track. the rest stays for now the same. And of course this is the last one added. So that runs quite nicely. Testing shows that it does work, with the exception here in this place, of course, where the marbles, bullets, whatever, keep rolling back. So that is still something that I don't like. And that's the end of this video. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. Very much appreciated. You can also follow me via Instagram and Twitter. Please show your appreciation by making a donation via either PayPal or Wired. And you can also become a patron and may have your name mentioned on my website and within videos. For more information and my website, please see under this video. Also, the last segment shows the information. Since still not everything has been resolved, such as this and that, things are going to be continued. For now, thanks for watching, stay safe, have a nice day, bye bye.